In this video, I'll show you how to think about code when we look at design patterns. What should we look at and what should we not look at? We will be focusing on this package here, and it actually tells us what design pattern we'll be looking at. But we'll start with reviewing the classes in it and try to think about what is relevant and what is not from a design pattern perspective. So design patterns are usually described using a set of classes and methods, their interactions, and the consequence of using the design pattern, the purpose of it. So it's important that we understand the purpose of the classes that we're looking at. What are their roles and what are the main interactions between them? We might start with a class such as main. We understand that this is the entry point, and the example, which provides the output that you see in the console below, is a description of two objects. And we use first something called a DAL, whatever a DAL is. DAL is a data access layer. So we will have to understand a little bit about the domain in order to discern what design is relevant in this domain. Data access layer means a layer between the serialized representation. In this case, a set of XML files, such as this, with 2 people, and this, with 3 employments. And its object structure. This is one object, one person. This is another object, another person. Okay, so in this example, we understand that we obtain objects that can act as person objects, and for each of them we simply print their age, their ID, name, age, and employments. Okay. So this might look like very complicated code to do a for loop, but it basically just prints 2 objects. Now, one of the things to think about is, okay, so we know that this is about fetching objects. The DAL class is responsible for fetching objects. What design patterns could be interesting there? Well, we might have some structural design patterns, such as a composite. When do we use a composite? Well, usually when we have a large structure of similar objects, maybe. So recursively, an object of type A might contain other objects of the same type A. When we create objects, there are a number of possible creational design patterns. So we might have a factory method design pattern, or an abstract factory, or a builder design pattern at work here. The behavior of these objects is not something that we focus on. The application seems to be focused on merely reading and printing objects. So no fancy behavior, probably we don't have any such design patterns here. But what specific design pattern could we be using for this example? We have to, again, understand a bit about the domain. So here it says, if we try to look at the output a bit more closely, trying to access uninstantiated field employments, and then there's an output line describing the person, or rather the ID, name, age, and employments of a person. So trying to access uninstantiated field, is that output from any of the methods in class person? No. Which tells us that obviously whatever person DAL does, this object, it doesn't return a set of person objects, but a collection of objects that can act as people, act as person objects, so subclasses. So if we add, maybe I can add objects to this diagram. No, I cannot. maybe I can do type hierarchy. So if I look at person and I, in this type hierarchy, try to see if there are any static subclasses to person, I see that there are none. Then how come we get output that doesn't come from the class person, but comes from some other class that can act as a person? The only design pattern which allows us to do this, to allow some other class to act as the base class and provide additional functionality. And in this case, if we just try to decipher what the first line says, trying to access uninstantiated field. So if we load something from an XML file, people.xml, and we look at this, we see that obviously there aren't any employments here. But somehow, after the first line is printed, trying to access uninstantiated field, when we do print employments, there is a set, and we have made no explicit invocation. If I go back to the main file, we've made no explicit invocation to load employments.xml. Rather, in the person class, we see that there are some annotations to the method getEmployments, identifying the file to use and the foreign key, which should identify the current person maybe. Using this information, it seems, we've populated a list of employments to be printed. And all of this seems to happen in a class that we've not created. And the only class that we have accessed is the class called DAL. So in this DAL, we can see that there are two classes in it. One called the lazy loader, which by name seems to imply that it loads something lazily. And it so happens that this class also contains this debug information. Printout trying to access uninstantiated field and then description of the field. Now, what is not interesting here is all this code. So there's not a design pattern which tells us that if value is not empty then, or if there's a foreign key getter or something. What a design pattern tells us something about is the interaction between different classes and the purpose of those interactions. Sometimes there are convenient conventions, such as having a proxied object be called a proxied object. But here, the proxy that we get for a person object is something we create by using a lazy loader. The name lazy loader might be a good name because it tells us that irrespective of the object that we act as a proxy before, the common functionality this class provides is that it can load related objects lazily. So it doesn't say that this is a proxy. However, there are other methods such as create proxy here and get proxy class, and those methods might be used to indicate that this somehow has to do with the proxy design pattern. However, there might be other general methods used, such as invoke and perform or whatever. And those are actually not interesting. What is interesting is first trying to understand the intent of this small application, loading objects and printing them, and understanding that we don't get the person object, it seems to be declared here, but something else, and understanding that whatever we get can act as a person. And that which acts as a person must be a subclass of person. And then there are some possible design patterns which we can come to think of when we consider the actual functionality. Not that we have to understand all details of it, but if we just look at that there is an XML file we load, and in that XML file obviously there aren't any employments. So somehow, by some magic, the other file called employments.xml seems to be loaded. So we can sort of figure out this must be what seems to be happening due to this line of code. And then that should lead us to the design pattern that allows us to substitute a class for another in order to provide transparent functionalities such as deferred loading in this case.